Here's another video short for you today. This one is about how to factor a trinomial when we have common factors. So whenever you're factoring, you always want to do a quick scan and ask yourself, does there exist a greatest common factor? And if you can train yourself to always ask that question, then you will always get these right. So we're going to scan this for greatest common factor. They don't all have n's, so that's not a common factor, but they all are in the families of fives. So 5, 10, and 20. So the GCF is 5, and so when we factor that out, we're going to create a trinomial space, a space for 3 terms. So we have n squared plus 2n plus 4. So how did I do that so quickly? I just divided all these terms by 5 so that when I redistribute the 5, which I don't lose, it stays on the outside. Always put your GCF outside the grouping that you create. So 5n squared, 5 times 2n is 10n, 5 times 4 is 20. And so now I can go ahead and do my trinomial factoring where I'm actually going to have 1, 2, 3 factors now. So the GCF does not get lost from line to line. And so now you factor this as you have been. So the first term is factored n and n. The last term's factors I want are 2 and 2. I could have done 4 and 1, but I'm trying to add to a 2. And so when I try this out, what I love about this is I went the route that I know, and yet this right here was fully factored because this trinomial is prime. Because if I factor this with a 4 and a 1, I cannot add to a 2 with 4 and 1, and with 2 and 2, I can multiply to 4, but I cannot add to 2. So that's normal. You attempt a next step, you find out it wasn't going to work, and you realize up here it was done. So here's the next one real quick. Greatest common factor, you ask yourself. Well, yep, I see a 2, a 22, and a 60, so I say the greatest common factor is 2. So again, it's not lost. It shows up here outside the trinomial grouping. K squared times 2 will get me 2k squared. 2 times what gets you 22k? That would be 11k. And 2 into 60 is 30. So I'm talking about it in a few different ways because you can think about it in a few different ways. So 2 times k squared is 2k squared. 2 times 11k is 22k. 2 times 30 is 60. So now we ask ourselves, are there factors of 30 that will add to 11? And yes, there are. So I'm still going to factor k squared came from these two positions multiplied together. The 30 factors I want are 6 and 5. And when everything is positive, so is it down here. And notice that that will get us k squared, 5k, 6k, which add to 11k. 6 times 5 is 30. So this is fully factored with 1, 2, 3 factors. The last one lets us practice some negatives. So again, you ask yourself, is there a greatest common factor? Yes, there is. I see 4 is the greatest common factor. I'm not going to factor out a negative 4 because this was not also negative. If at all possible, you want this term to always be positive. So if it was negative, even if not all of those were negative, you want to factor out a negative also. So let's just take out the 4, create a trinomial space. So what times 4 gets us v squared, or 4v squared is v squared. 4, or negative 4v divided by 4 should get me a negative v, because 4 times negative v is negative 4v. And what times 4 gets me negative 8? That would be negative 2. So now we ask ourselves, can this be factored further? So factors of 2 are 1 and 2, and I can add those together to get a negative 1 as long as my 2 is negative and my 1 is positive. So we take a look. V times v is v squared. Negative 2v plus 1v is a negative 1v. And positive 1 times negative 2 is negative 2. So this is now fully factored with 1, 2, 3 terms.